Hey everyone, and welcome back to The Explainer. Today, we are tackling a massive, rapidly evolving topic that honestly every single organization building with AI absolutely needs to master. We're unpacking Paul Ranjan's definitive field manual on AI economics, which is simply titled Token Economics. Listen, if you've ever needed a stiff drink after opening your monthly AI infrastructure bill, yeah, you are definitely in the right place. I'm genuinely thrilled to get into this one because it really takes the complete mystery out of those massive costs that just keep surprising development teams.
Okay, let's dive right into this. Paul Ranjan sets the stage with a pretty brilliant observation right off the bat. Basically, every technology era has its defining economic unit, right? The mainframe era had CPU hours, the cloud era had gigabytes, but the AI era, it meters tokens. And here's the catch. Unlike cloud servers, you can't just reserve tokens, right-size them, or, turn them off at night. The meter literally never sleeps. They're consumed dynamically, and they multiply silently in the background. So, to make sense of all this, we're going to conduct a bit of a forensic audit. Here is our roadmap. First, the foundations of a token. Second, the physics of pricing. Third, the anatomy of an AI bill. Fourth, the three regimes of spend. Fifth, the optimization playbook. And finally, context engineering. All right, let's kick things off with part one, foundations of a token. Think of writing a large language model like riding in a taxi in a foreign city. You're paying for every single tick of that meter. And that meter, it takes in tokens, which is the atomic unit of AI computation. Basically, it's the smallest fragment of text a model can read or write. As a general rule of thumb, one token is about 4 characters of English, or roughly 3/4 of a word. But, and this is a massive but, here's a surprising fact you absolutely have to build into your cost models from day one. Tokenizers are overwhelmingly trained on English. So if you're building for non-English languages, say Filipino, Japanese, or Hindi, you're facing a structural penalty. That exact same meaning can consume 2 to 4 times more tokens. That means you're paying way more and you're waiting longer, literally just because of the language. Crazy, right?
Moving right along to Section 2, the physics of pricing.
So if you've ever glanced at an AI rate card, you've probably noticed that output is always 4 to 6 times more expensive than input. Why is that? Well, think of reading input like speed reading. When a model reads your prompt, it's like a speed reader taking a quick photograph of a page. It sees the whole thing in one instantaneous parallel glance. We call this the prefill phase. But writing an answer? That's entirely different. That's like careful, deliberate calligraphy. The model generates output sequentially, just one careful stroke or token at a time. And for every single new stroke, it has to look back and recheck everything it's written so far. Photography is cheap, but calligraphy, very expensive.
To break down the physical foundation of this, you have the prefill phase, where all input tokens are processed at the exact same time. It's bound by compute power, which actually makes it incredibly fast and really cheap. But then you have the decode phase for output, one token at a time, each one attending over all the prior tokens. This phase is bound by memory bandwidth. That makes it slow, and it makes it expensive. This sequential bottleneck is the literal physical reason you're paying that 4 to 6 times price premium on output tokens.
Okay, let's zoom out a bit. Section 3, anatomy of an AI bill. An enterprise AI bill is a lot like a restaurant check. You clearly remember ordering the steak, which is the model inference, but then you look at the receipt and realize you're quietly paying for 8 other appetizers you barely noticed, like embeddings, orchestration, and observability. But I really want you to pay attention to one specific line item here, reasoning. These are hidden deliberation tokens. They bill at that expensive output rate, but they remain totally invisible in the final response you get. This sneaky complexity is exactly why you absolutely need a centralized AI gateway. Think of this gateway as your building's main electrical panel. It acts as a central fuse box that tracks all these hidden costs across all the different line items. It ensures you aren't just flying blind and silently undercounting your spend by massive multiples.
That brings us to Section 4, 3 regimes of spend.
Look, not all workloads are created equal. A simple chatbot, it just sips tokens. A RAG application drinks them. But an agent turns the tap wide open. Check out this number. $7. That is the massive, very real potential cost of just a single 200-call coding agent session using a frontier model. And this is exactly where your AI gateway's active defense becomes your best friend. By setting a hard breaker limit at the gateway, let's say a $2.50 limit for a specific session, you can dynamically intercept these runaway loops. This active defense protects your entire month's budget from just disappearing in a single afternoon because an agent got stuck in a loop.
You might be wondering, why on earth does a coding agent multiply costs so drastically? It's because an agent runs in a loop, and every time it loops, it forces you to pay 4 distinct bills all at once. First, you're paying for large context windows, like dumping entire code repositories in there. Second, you're paying for long execution loops that can be dozens or hundreds of calls. Third, you're paying for incredibly verbose tool outputs, like massive build logs. And finally, you're paying for reasoning, which is often toggled on by default. Every single iteration forces the model to reread that constantly growing transcript. Ranjan calls this compounding quadratic math the rereading tax. So how do we fix this? Section 5, the optimization playbook.
How do we drastically cut down this AI spend without sacrificing the actual quality of our output? Well, first things first, you need to enforce hierarchical budgets at your gateway. We're talking hard caps that cascade down, from the org level down to the team, to the project, and finally to the agent and session level. Once that fuse box is set up, you use your absolute biggest lever, caching. Providers will actually sell you the exact same tokens at about a 90% discount. But there's a catch. You only get that discount if you ask for them in the exact same order. This requires incredibly strict prompt discipline. You've got to order your prompts by stability. You start with the system prompt, then your tool schemas, then your few shot examples, and finally, you put the volatile changing user turn at the very end. But here is the absolute golden rule. Never, ever poison the prefix. If you drop a timestamp or a random session ID at the very top of your prompt, it instantly invalidates everything below it. You've just destroyed the cache for the entire session. It's all about architecture. By keeping those stable, cached elements at the top and firmly pushing all the volatile, changing elements to the very bottom, you unlock that massive 90% discount from the model's KV cache. You are literally taking a wildly expensive operation and making it highly efficient, just by formatting your text properly. The next massive optimization tactic is routing. Ranjan calls this the triage cascade. Think about a hospital for a second. An emergency room doesn't send every single patient with a scraped knee to the chief of surgery, right? They use a triage nurse. It's the exact same concept here. You shouldn't be sending everyday text generation to an ultra-expensive frontier model. By routing up to 70% of your simpler traffic to smaller, much faster models, and only escalating to mid or frontier models when tasks actually fail a quality gate, you can slash your costs by 40 to 70% immediately.
Finally, let's look at Section 6, context engineering.
Context engineering is the master skill that really separates the pros from the amateurs. It's like a scrub nurse handing exactly the right surgical instruments to a surgeon at the exact right moment, and then quickly clearing away whatever is no longer sterile. While prompt engineering asks, how should I phrase this? Context engineering asks, what should the model even see at this step at all? To stop an agent from hitting a wall of what we call context rot, where it just forgets things because the transcript is way too bloated, you use 4 high-leverage techniques: compaction to summarize conversational history, context editing to drop stale tool results, note-taking so the agent writes progress files outside its immediate window, and sub-agent isolation, where you send little workers out to do parallel research and they only return a tiny distilled summary.
So what does this all mean? The crucial takeaway here is that nobody's CFO actually thinks in tokens. As we wrap up this explainer, I want to leave you with this final kind of provocative thought. Are you managing your cost per token, or are you managing your cost per intelligent outcome? Because a cheaper model that fails 30% of its tasks and then requires a human to step in and review it, that might actually cost you way more in the end. You have to translate these technical unit economics into goodput, the actual successful intelligent outcomes that your business is paying for. Master that and you've mastered the AI era. Thanks so much for learning with us today. We'll see you next time.